In this module, we're looking at finding the surface areas of three-dimensional figures. And so surface area is defined as the area of all of the surfaces. Makes sense? So in this example, or this explore, we're taking the net of this right prism and trying to come up with a formula based on what it folds out to look like. So first thing is, in this diagram, the net, they want us to use the measurements from the three-dimensional figure to fill in the blanks for the dimensions. So this would be my height. Maybe this would be A, B, and C. So what type of figure is formed by the lateral faces of the prism? That's this. So hopefully you noticed that was a rectangle. Write an expression for the length of the base of that rectangle. That would be A plus B plus C. And how is the base of the rectangle related to the perimeter of the base of the prism? They are the same. So the lateral area L is the area of that rectangle. Write a formula for L in terms of H, A, B, and C. So the base of the rectangle is A plus B plus C, and the height of the rectangle is the height of the prism. And then it's asking me to write a formula in terms of P, where P is the perimeter of the base of the prism. Well, we already said that they're the same thing. So if B is the area of the base of the prism, well, there's two bases, so surface area would equal lateral area plus 2 times the area of the base, which is the same thing as S equals perimeter times height plus 2 times the area of the base. In example 2, in the interest of time, I have to skip a few things. Suppose a rectangular prism has length L, width W, and height H as shown. How can we write a formula for the surface area of that prism in terms of L, W, and H? Well, in a rectangular prism, I would have 2 faces that would look like that, whose dimensions are L and H. So that area would be 2 times LH. Similarly, I would have 2 of these rectangles whose dimensions are L and W, so 2 LW, plus I'd have 2 of these rectangles whose dimensions are W and H, so 2 WH. So that's another way that you can find the surface area of a rectangular prism. And so here's the formula that we came up with on the previous screen, that L is P times H, and S, surface area, is that lateral area plus 2 times the area of the base, which is also perimeter times height plus 2 times base. And you see in example 1 part A, they are using that formula to find the lateral area and then the surface area. A little bit more on our own here, and a little bit more difficult because this time I don't know all of the measurements in our figure. So thankfully the base is a right triangle, so when I know 2 sides of a right triangle, I can use Pythagorean's theorem to find the missing side. So c squared will equal 10 squared plus 24 squared, which is 676. And when I take the square root of that, I get 26. So the perimeter of my base is 10 plus 24 plus 26, so that's 60, times the height of my prism, which is 20, so L is 1200, that I'm going to add in order to find the surface area. I'm going to add to 2 times the area of the base. And since the area of the base is a triangle, and the area of a triangle is found by doing 1/2 base times height, that's why you see this 1/2 here. So the base and height of that triangle are 10 and 24. So that's 240 plus my 1200, which is 1440. I have a gift box with dimensions 9.8, 10.2, and 9.7. I'm asked to estimate the amount of paper. So let's estimate. Let's estimate this is approximately 10, this is approximately 10, and this is approximately 10. So since it's a rectangular prism, let's also consider that if this is a cube, then all 6 of the faces are the same. So the cube surface area would be 6 times side length squared. So if I use that to make my estimate, then I've got 6 times 10 squared, which is approximately 600 square centimeters. In the interest of time, I'm only going to do number 5 here. So, in order to find its surface area, I need to know the perimeter of the base. This is a triangular prism, which means the base is the triangle. I don't know this length. I'm going to call it A. So I'm going to use Pythagorean's theorem in order to find it. A squared plus 3.6 squared equals 6 squared. So we've got 3.6 squared is 12.96. 6 squared, of course, is 36. A squared is 36 minus that 12.96. So that's 23.04. And then I take the square root of both sides and get that A is 4.8. So now I know this length, and I can use it to find perimeter. So perimeter of my base will be 4.8 plus 3.6 plus 6. And that's 14.4. The height of my prism is the 8.5. The capital B is 1/2 base times height for the triangle here. So that would be 1/2 times 3.6 times 4.8. And my capital B is 8.64. And so now I know everything I need in order to plug into the formula for surface area, which is PH plus 2B. So 14.4 is the value of P, times 8.5 is my H, plus 2 times 8.64 was my B value. And when I type this all into my calculator, I get 140.53 square inches. Moving on to finding the lateral and surface area of a cylinder. And if you recall, when we dealt with the volume of a cylinder after we had seen the volume of a prism, those formulas were very closely related. Similar idea here. In the surface area of a prism, we're taking the perimeter of the base and multiplying it by the height. So perimeter of a rectangle corresponds to the circumference of a circle. So that's why you see it as 2 pi r h, and then plus 2 times the area of the base. Well, the base is always going to be a circle, so 2 times pi r squared. And in example 2, part A, you see that they're using that formula. We know what the h is, we know what the r is, so we're just plugging in. So in the context of this problem, we're creating an aluminum can, so we want to know how much aluminum we need. That's the entire surface area. And then we want to know how much paper we need for the label, and the label is going on the lateral surface of the cylinder. So at the very end, you see them evaluating the pi for the lateral area to find how much paper is needed, and then they evaluate the pi for the total surface area to find out how much aluminum is needed. Same idea for this problem. I know that my radius is 2.5 because it has to be half of the diameter that was given to me. My height is 2, so my lateral area is 10 pi. My surface area will be that 10 pi plus 2 times pi times r squared. So I evaluate that. 2.5 squared times 2 is 12.5 plus 10 will then be 22.5. So the amount of paper needed is that lateral area 10 pi, which I evaluate the pi and get approximately 31.4. And then the amount of aluminum needed is 22.5 pi, which is approximately 70.7. Here we're finding the surface area and lateral area. Again, in the interest of time, I'm going to do just one of these. I'll do number 8. They didn't give me the radius, they gave me the diameter, so I know my radius has to be half of that, which is 36. My height is 80, and now I know everything I need to plug into the formula. L is going to be 2 pi times 36 times 80. Which is 5760 pi. And then my surface area is going to be that value plus 2 pi times 36 squared. So 36 squared times 2 plus, oops, I dropped my pi, 5760 gives me a total surface area of 8352 pi. So the aluminum needed is that total surface area, so 8,352 times pi, which is 26,238.6 square millimeters, and the amount of paper needed is my lateral area, 5760 times pi, which is 18,095.6 square millimeters. Finally, we're looking at composite figures now. So be very mindful that if you recall, when we were doing volume and we took a hole out of a surface, we ended up subtracting the volume. But when we're talking about surface area, having a hole in a figure actually adds a surface. So just be mindful of that. So in example 3, part A, you see that they found the total surface area of the prism. And then they found the lateral area of the cylinder. And they added and subtracted some stuff. So let's see what they added. They took the surface area of the prism and the lateral area of the cylinder, and then subtracted the two bases so that we're not counting that area. Again, there's a hole here and a hole here. And so that's what they subtracted here. So in part B, we're going to start by finding the surface area of the prism. So that perimeter of the base is 9 plus 4 plus 9 plus 4, so that's 18 plus 8, which is 26. The height of that prism is 5. And then 2 times the base and height of the base of the prism. And when I type this all into my calculator, we get 26 times 5 plus 2 times 9 times 4. That's 202. Then we're going to find the lateral and surface area of the cylinder. So lateral area is 2 pi times r times h, which is 12 pi. So the surface area will be 12 pi plus 2 pi times 2 squared. So that's 2 squared is 4, 4 times 2 is 8, 8 plus 12 gives me 20 pi. And so now let's see what they have us adding, subtracting. They have us starting with the prism's surface area, adding to it the cylinder's surface area, so far so good, and then they're subtracting 2 areas of the cylinder's base. And so you might be wondering, why are they subtracting 2 of them? So first of all, realize that in here, we're including 2 bases of the cylinder, but notice that only this one is a surface of my composite figure. So that's why I need to subtract 1 circle from here. Then why am I subtracting another one? Because in here, I'm finding the entire surface area of the prism. Notice that this is kind of a hole in my prism. So that's why I need to subtract another circle. So now let's just substitute the values in. The prism's surface area was 202. The cylinder's surface area was 20 pi. And then I'm subtracting 2 pi times 2 squared. So I've got 20 pi minus 2 pi squared, 2 pi times 2 squared, excuse me. So that's 202 plus 12 pi. And when I evaluate that, I get approximately 239.7 square centimeters.